All right, so I've zoomed out here because there's one more thing that we have to discuss concerning large double-stranded DNA viruses. So in these viruses, the genes are actually transcribed in 3 waves. So I'll write that here of transcription. And basically, each wave will prompt the other wave to start transcribing. And so we have 3 waves. And these are called the immediate early, the early, and the late. And basically, a few of the early genes, once translated, will travel back from the ribosome to the nucleus, and they will initiate both the replication of the rest of the genome, as well as the transcription and the translation of the late genes, which are involved in the assembly, of the final virus structure, the virion. So, some examples we'll list down here. Examples of DNA viruses, or double-stranded DNA, viruses, that you guys might know are the Epstein-Barr virus, which is more commonly known as mononucleosis or mono. I'm sure someone you know has had this. A lot of people get it in high school. And this is a picture right there. Also, a really common double-stranded DNA virus that many people have heard of is the herpes simplex virus. And another common virus is the human papillomavirus. And got some pictures of those in here. So we're going to zoom out. Oops. So that is the class 1 double-stranded DNA. We are going to change colors. Let's see. And we're going to come over here to the class 2. Single-stranded DNA viruses. Right. So some families in this classification are Parvoviridae. So the way you can tell if something is a family is it'll have the Viridae right there. Oops. And the Anelloviridae. And we'll talk about in a second, after we're done with the replication process, we'll talk about a few examples that fall into these families. So, like before, we're going to go ahead and just draw out the full process and then go back and talk about it. So first we start with single-stranded DNA. This has to be converted to double-stranded DNA. And then it is the exact same process as over here. So when we look at this right here, all that is going to be pretty much mirrored over here. Right. So we have replication into another single-stranded DNA genome that eventually will go in the assembled virion that's going to be released from the cell. Here you're going to have, again, I have to write so small, transcription into mRNA, and then finally translation into the proteins that will make up the nucleocapsid. And then we put these together and they assemble. So, basically they follow pretty much the same process as the double-stranded DNA. They're going to enter the host nucleus. So we have our virus will enter the nucleus and we'll go ahead and start replicating. The only difference is that DNA replication and transcription requires 2 strands of DNA. So the single strand must be converted into the double strand by DNA polymerase. So just abbreviating here, SS single strand, DS double strand. And again, abbreviating DNA polymerase, DNA pol. Okay, and yeah, I'll put 2 here, replication. Alright, so one example of a single-stranded DNA virus is the parvovirus. So this falls in the family that we talked about before, the Parvoviridae family. And you might have actually heard of this virus. It infects dogs. And so if you have a pet, you might be familiar with this. Hopefully not, because it makes them very, very sick. I actually, fun fact, I worked in a vet office and we actually saw a few of these cases. So that is an animal virus, but single-stranded DNA actually usually infects bacteria and plants. So usually, I'm running out of room here. Bacteria and plants. Also, something to note about these viruses, they are very, very small, and they are therefore dependent on the host cell to supply not only the DNA polymerase and the RNA polymerase too, but also the host cell needs to supply enzymes to catalyze replication and transcription. Alright, so what we've talked about so far is class 1, double-stranded DNA, and class 2, single-stranded DNA. And we're going to go up here. So if we look at this, everything we have left is RNA, except for this right here, the DNA viruses that reverse transcribe. So moving on down here, we are going to start. I'm going to zoom in a lot because we're going to need a lot of space for this one. We are going to start on class 3, which is double-stranded RNA viruses. All right. So again, we're just going to go ahead and lay out the summary. So we start with double-stranded RNA genome. And first, something we need to talk about is there is something something that the RNA double-stranded virus uses is RDRP. So this stands for RNA dependent RNA polymerase. And this is something that the virus brings with it, and we'll talk about that in just a second. So, the double-stranded RNA genome is going to be transcribed right here. And it's going to be transcribed by RDRP. into mRNA. And you're probably thinking, well, what the heck? We did replication first on the other ones. Well, those were DNA viruses. And so right here, we can't just do straight replication. We have to do it this way and go to mRNA. So this side over here is going to be the part that makes the genome. But on the other side, we are going to have transcription, again by RDRP. Sorry, this is also cramped. Alright, and that is going to make, again, mRNA. The reason why we're repeating this is just to show what happens on both sides while we're trying to do the genome on this side and the proteins on this side. And that mRNA is going to be translated into proteins that are going to make the nucleocapsid. Alright, and so it's a little easier to see. I'm just going to go ahead and make this one a little longer so that we have it all on the same plane. And then these put together, we are going to assemble. And the last step is using RDRP here. It's probably a little short. We are going to end up with, like the original genome, double-stranded RNA, which is all in the capsid, which is, again, the surrounding protein that encloses the genome.